In this video, we're going to have a look at how we can make a mathematics help sheet for use within a test. One thing I should mention is this video is quite long, so what I'd recommend is watch the first part up until, say, doing the first examples, and make sure you watch the part where I'm going through some of the Year 11 examples, and then skip to the end if you feel like you don't need to read or watch the rest. But otherwise, so a cheat sheet is something that you'll use when you're doing a test as a reference of things that you can't remember. So a cheat sheet, it's not a supplement for things you didn't study, but rather it's a supplement for things that are just really hard to commit to your memory. So before we jump into it, we'll have a look at a few examples. So what I've got here are some cheat sheets, or help sheets as I like to call them, from a Year 11 test. Now, if you look at some of them, they're quite complicated. So this one here, it's got quite a lot of information on it, purely because the topics you cover in Year 11 have quite a lot of subject matter. Now, if we go down, what you can see is that people have all different sort of styles to doing their help sheets. So this particular individual here is obviously quite confident, and same with this person here. Whereas this one here, there's quite a lot more information on it. So as you can see, there are lots of different styles to designing a cheat sheet, but the fundamental idea is you want to make it such that it's a supplement or a help for you in the test. It's not going to be an answer sheet. It's simply something that you use when you get a little bit stuck. So when we're doing our cheat sheets, what we're going to do is we're going to have a look back at all the subject matter that we've covered, and then pick out what we think we might need. So a good place to start is the worksheets that you've been working on through the last topic. Now, if we go back to firstly perimeter, what we do when we're doing a help sheet is we have a look at the questions that we've done and we scan down the page. And what we do is we identify things that maybe we can't really remember. So simply scanning down like this, I've already picked out a few things that I'd probably want a little bit of help on. So the first things that I pick out are firstly, one, these circles over here, and then secondly, the perimeter of triangles. So notice that we're simply not just counting up sides, but rather we have to do some calculations to find unknown sides. So what I'm going to do is I'm going to start with perimeter. So I'm going to go perimeter. Now, as mentioned, the first things that I decided I'd need or I'd like a little bit of help on in a test is I'm not going to be able to remember the formula for these circles or these partial circles, and I'm not always going to remember Pythagoras' theorem for the triangles, so I'm going to add those two in. So I'll start with the easier one, and we'll go a triangle like so, and then we'll label it C, A, and B. And we know from our past set, using Pythagoras' theorem, it can be simplified down to C, or the side length C, is equal to the square root of A squared plus B squared. But what if it's not the hypotenuse? Well, if we're trying to find, say, one of the other two sides, then it's going to be C squared take B squared, all square rooted. Awesome. Now, for the circle, area of a circle is going to be, or I should say circumference of a circle, that's going to be 2 pi r. And while we're at it, we'll throw in area as well, and we know the area of a circle is going to be pi r squared. So what we've done here is we've got two useful formulas that we often seem to forget. Now, one of the important things to mention with a help sheet is that you always have limited amount of space. So you want to make it compact, but at the same time you want to make it readable. Now, next thing I'm going to do is I'm going to do the area and perimeter of parts of a circle. So to do that, I'll draw a little diagram. That wasn't too bad. And then I'll label it R. And then the angle at which designs the rest of the part of a circle. The perimeter in this case is going to be, well, it's pi theta all over 180. If you want to see where that came from, then go back and have a look at the reference sheets or the worksheets. And the area, of course, is going to be pi r squared, whoops, theta. And again, if you want to look for where this came from, then go back and have a look at the worksheet. So this one, or you could look at the area worksheet here. Alright, another thing we often forget is the triangle itself. Area of a triangle is, say we've got something like this. So it's not a right angle, but we're given the height, h, and we're given the base, b. Then we can work out the area of this triangle by going a equals half base times height. And this works for a right angled triangle as well. Simply multiply the base and the height together and then divide it by 2, and that will give you your area. So what we've got here is some basic perimeter and area calculations. Now, two more shapes that I'd recommend putting in are the kite, and we'll call this side P, and we'll call this one Q. And the area of a kite is going to be, or it's not going to be, it is half P times Q. And similarly, we're going to go a trapezoid. And to calculate the trapezoid, we find the height, and then we find the side lengths. We'll call those A and B. And the area of that is simply going to be half A plus B, so the average of the two long sides, multiplied by H. Alright, so that will conclude most of the useful formulas I'd find for perimeter and area. Again, you can go through and have a look at, say, the area worksheet that we did and see if there are any particularly useful shapes in there or calculations in there that you may need. But keep in mind the help sheet, it's not a supplement for not doing study. Again, you need to make sure that you've done the appropriate amount of study. If you're walking into a test completely unsure about how to use a formula or really not well practiced with applying a formula, then it means that you haven't prepared properly. The help sheet isn't a replacement for study, but rather it's simply an assistance in the case that you perhaps forget something or have a mental blank during the test. Now, going on, we've done area and we've done perimeter. The next one we need to do is surface area. So again, surface area is just a different application of area itself. So the way in which we're going to do this is, again, we pull up the worksheets that we've worked on and we just have a scroll down and look at the information that's involved in it. So what we can see is the only challenging questions that we've done on surface area have been regarding the surface area of cylinders. If we go down a little bit more, there's some extension work, but this is year 10 stuff here, so we don't have to cover this in the test. But this stuff here. So what I'm going to do is I'm going to draw a little diagram of how to do surface area. And one thing to keep in mind is that we've got limited space that we can work with. So what you want to do is use your space effectively. So you don't want to put copious amounts of information on, or else you'll run out of space to work with. And similarly, you don't want to put copious amounts of information on because it will be hard to find the useful information. So what I'm going to do for surface area is simply show the net of a cylinder. And if this is the radius, and this is the radius here, and if this square section here is just the unraveled side section of the cylinder, then the space here, or the length here, is simply going to be 2 pi r, and this will be the height, same as what we saw here. So therefore, the surface area of a cylinder, of a closed cylinder, is going to be 2 pi r squared, because we've got two circles, plus 2 pi r h. Now again, you simply can't just use this formula as a blanket formula for all questions. You have to take into account the application of the question. So say for example, in question 1 here, it says the outer surface area of the following cylinders are hollow throughout. So there's no caps on this one. This one is completely solid, so in which case you could use this formula here directly. And this one has no top, so you're going to have to modify this formula here. So it's simply a case of look at the net and see what you have. If there's no top on it, then obviously one of these circles is going to be gone, so the surface area is going to change. Another one to take into account is the saucepan here. So notice a saucepan, it's sort of hollow in the middle because it's got to hold stuff. So in which case the surface area is going to change. Alright, so that's all I'd personally put on my surface area calculation area on my help sheet. But again, you might choose to put more things on there because these help sheets are going to be individual for everyone. So it's your task to go through all of the worksheets and see what you think might be relevant or you think might be helpful for you in the test. Alright, moving on from there, we're going to go to volume. Now, once again, to decide what I'm going to put on my volume area of my help sheet, I'm going to bring up the worksheet on volume and have a quick look through. So question 1, we're looking at prisms. Question 2, we're looking at volume of cylinders. Question 3, we're looking at volume of these prisms or these extruded shapes. And then going down from G onwards, it looks like we've got these composite shapes here. So again, extruded but composite. Then, okay, some really interesting ones at the bottom. Now, what I'll do is simply, I pick out the shapes that I'm a little bit unfamiliar with, and perhaps I feel that I might have a mental blank if I'm doing the test with these. So what I'm going to do is I'm going to do the formula for the prisms, and I'll do it for the cylinders as well. So, drawing a prism, let's go something like this. Do that. And then let's give it some sides. So we'll call this one here A, B, and we'll call its depth C. Then the area, or the volume, I should say, volume of this prism is going to be A, B, C. So you simply multiply all of the side lengths together. Now for a cylinder, it's a little bit different in that for a cylinder what we do is we calculate the area of the top part and then we multiply it by its height. So the volume of a cylinder is going to be pi r squared multiplied by h. So it's as simple as that. Now the other shapes that we have here is we've got some interesting composite shapes and extruded shapes. Alright, and what we're going to find is that it will always give us the area up here and then it will give us the height. In this case, the volume of these strange looking shapes is simply the area of the top face multiplied by the height, and it's as simple as that. So that's all I'm going to put on my volume section. Again, you might choose to even put an example there of how to do some volume calculations, but I like to keep mine pretty simple. Move this for a little bit more space. Alright, going down. the final topic that we have to cover is the changing units. So to do that, I'm going to bring up my worksheet on changing units, and I'm just going to have a quick look down through it. And we've got changing from one dimension, 2 dimension, and 3 dimension. From what I can see, it seems to be fairly straightforward. You simply apply the rules from the first dimension, and then when you go to the second and third dimension, you simply add a square to the unit you're changing to. So when we're looking at changing, say, millimeters cubed to centimeters cubed, we know that the conversion from centimeters to millimeters is divided by, centimeters to millimeters is times by 10, but because it's in the third dimension, we cube that 10. So it becomes 450 millimeters cubed is the same as 450 divided by 10 cubed. Alright. So what I'm going to do for my help sheet is I'm simply going to copy out these red diagrams here. So doing that. And we're done. So pretty much if you've got space, you might choose to put an example on here somewhere. But for me, I think this is pretty simple, so I wouldn't put it on there myself. But again, it's always individual, and help sheets are always individual. As I showed you at the start with those various examples, people have help sheets with quite a lot of information on them. Some people have help sheets with not that much information on them. Another thing that people often like to do is break everything up with some highlighting. Again, it's just a personal touch to make it a little bit easier to read. You don't have to do it. There's no right or wrong way to do a help sheet, but of course there are help sheets that are more useful than other ones. So we'll leave it here for now. And yeah, hopefully I'll see some really nice help sheets when I'm marking your tests on Tuesday afternoon.